So I'm going to go through the solutions to the second exam I gave to my on-ground students for trigonometry this semester. And so there was two portions of the exam. There was a no calculator portion and there was a calculator portion. So the first portion was no calculator. And let's go through and look at the solutions of doing this exam. So if you're in my class, you might want to pause the video and look and see if you can do these problems, and then watch the video on the solutions just to help you prepare for the exam. So the first question that we have in front of us is solve the equation 2 sine squared theta is equal to 3 times the quantity of 1 minus cosine negative theta. And we're solving for the solutions on the interval between 0 and 2 pi. Okay, so looking at this, I'm solving for theta. I have an equation. There's a difference between equations and proving an identity. So when we're proving an identity, recall we can only work on one side. But here, this is an equation. Since this is an equation and we have both sine in there and cosine in there, right now, it looks like I need to rewrite this. So it's either in terms of sine or cosine. And since I have sine squared theta, I can use my trigonometric identity, cosine squared theta plus sine squared theta equals 1. And I can solve for sine squared theta in terms of cosine squared theta. So we would get 2 all times. Well, if I solve for sine squared theta in terms of cosine squared theta for that Pythagorean identity, we would get 1 minus cosine squared theta is equal to 3 all times 1 minus. So right here, I have this cosine of negative theta. So recall that cosine is an even function, and an even function is even if f of negative x is equal to f of x. And that is the case for cosine. So we can rewrite cosine of negative theta as cosine theta. So let's distribute. On the left-hand side of the equation, we're going to distribute the 2. So 2 times 1 is 2, minus 2 times cosine squared theta is 2 cosine squared theta. This is equal to, now distributing the 3, we get 3 times 1 is 3, minus 3 times cosine theta. I see this is quadratic, so I want to get everything to one side and set this equal to 0. I prefer the coefficient in front of my square to be positive, so I'm going to move everything to the right-hand side of my equation. So I am going to add 2 cosine squared theta to both sides. There's no other term that looks like that, so I have 2 cosine squared theta minus 3 cosine theta. And then I have subtracting 2 on both sides of my equation. I have 3 minus 2, which is plus 1. So this is all equal to 0. So now I'm going to go through and I'm going to see if this is factorable, which it is. So I'm going to factor this. So factoring this, I get 2 cosine theta. So I need something that is going to multiply to give me positive 1. And then in the end, that when I distribute out, I'm going to get this negative 3 cosine theta. So I know I need that negative middle term or term to be negative. So I'm going to put minus 1 and minus 1. So we have 2 cosine theta minus 1 all times cosine theta minus 1 equals 0. So if we distribute that out again, we would get the same thing that we had above. So now that this is completely factored and it's set equal to 0, I can set each factor equal to 0. So I'm looking at when is 2 cosine theta minus 1 equal to 0, and when is cosine theta minus 1 equal to 0. So let's isolate the cosine theta for each equation. So for the first equation there that I have written out, I'm going to add 1 to both sides and then divide by 2. So I'm looking at when is cosine theta equal to 1/2. On that second equation, I would add 1 to both sides. And so I get cosine theta is equal to 1. So I'm only looking for the solutions that fall between 0 and 2 pi for theta. So cosine is positive in 2 quadrants. It's positive in the first quadrant and the fourth quadrant. So let's first think about when cosine is positive in the first quadrant. Since my intervals are in terms of radians, I'm going to put my answer in terms of radians. Cosine theta is 1/2 at pi thirds, when theta is pi thirds. So we have theta is equal to pi thirds. So in the fourth quadrant, my reference angle is pi thirds. To get that, I would look at 2 pi minus pi thirds. So that would be 5 pi thirds. There's only one value of theta between 0 and 2 pi that would make cosine theta equal to 1. And that's when we have 0. So we have 3 solutions to this equation between 0 and 2 pi, not including 2 pi. Okay, so let's look at the next example or problem. Okay, so in this next problem, it says find the exact value of each expression. You can use the method of your choice. So there's a couple different ways that we can approach doing these problems. First one, I have cosine of 165 degrees. So I can think about 2 angles that I can add or subtract to get 165 degrees, and angles that I know without a calculator. So looking at this, I know 120 degrees, and I know 45 degrees. So I can rewrite 165 degrees as cosine of 120 degrees plus 45 degrees. So now I can use my formula for the sum of 2 angles for cosine. Recall cosine is cosine, cosine, opposite angle, or sine in between the angles. Sine, sine. So this would be cosine of 120 degrees, cosine of 45 degrees, opposite sine minus sine of 120 degrees, sine of 45 degrees. Cosine of 120 degrees. Well, that falls, 120 degrees falls in that second quadrant. I know cosine is negative in that second quadrant. My reference angle is 60 degrees. Cosine of 60 degrees is 1/2. So I have negative 1/2. Cosine of 45 degrees, that's root 2 over 2. Minus sine of 120 degrees. Sine in the second quadrant is positive. So my reference angle 60 degrees, sine of 60 degrees, I get back root 3 over 2. All times sine of 45 degrees, which is root 2 over 2. So multiplying negative 1/2 times root 2 over 2, I get negative root 2 over 4 minus root 3 times root 2. They have the same index of the radical, so we can multiply those numbers that are underneath the radical, which are called the radicands, together and put it just as 1 square root. So this is the square root of 6 all over 2 times 2, which is 4. So rewriting this as 1 fraction, we already have a common denominator. So this is negative root 2 minus square root of 6 all over 4. So that was one way to approach it. Let me go through the second way. You might have thought about looking at this as a half angle. So let's see if a half angle works. So let's multiply 165 by 2. Which would give us 330 degrees with a reference angle that would be 30 degrees, which we know. And so we can use our half angle formula. So looking at this, put a line here. We can rewrite cosine of 165 degrees as 330 degrees divided by 2. This is equal to, so recall for the half angle, we have a plus or minus in front of that radical, and we had to decide, are we going to use the positive or the negative? Well, let's look at that 165 degrees, figure out what quadrant you fall in, which is the second, and determine is cosine positive or negative in that quadrant. Well, it's negative, so we're going to use the negative in front of that radical. So we have minus the square root of 1 plus cosine of 330 degrees all over 2. So let's evaluate cosine of 330 degrees that's underneath our radical. So we get here, this is negative square root of 1 plus reference angle is 30 degrees. We're in the 4th quadrant, cosine is positive. That's going to give me root 3 all over 2. That radical should be including our denominator, all over 2. Let's get rid of this complex fraction underneath the radical. There's multiple ways that you can do this. I tend to like to multiply by that fancy 1 that is equal to the least common denominator of all the fractions within that complex fraction. So when I distribute out my least common denominator, all the fractions in there would disappear. And so we would get back here, this is equal to negative square root of 2 plus root 3 all over 4, which is equal to the negative, the square root of 2 plus root 3, that's all underneath that main radical, all over the square root of 4, which is 2. So our answers look different, but if you plug those into the calculator, which you wouldn't have on this portion, you would see that they would be identical. So same idea for the second part of this question, which is saying evaluate sine of 15 degrees. Again, we're going to evaluate this with a method of your choice. We can also, in this problem, do it 2 separate ways. We can think about 2 angles that we're adding or subtracting to get 15 degrees, and those angles should be ones that we know how to evaluate, or we can use the half angle formula. So let's first look at it by using a sum or a difference. I noticed that 15 degrees could be rewritten as 45 degrees minus 30 degrees. So doing that, I would have sine of 45 degrees minus 30 degrees. So difference of angles for sine, or sum of angles for sine, remember, was sine, cosine, and in between, we had the same sign that was in between the angles of our expression. So here we would have sine of 45 degrees, cosine of 30 degrees, minus sine of the other angle, 30 degrees, cosine the other angle, 45 degrees. Well, sine of 45 degrees is root 2 over 2 times cosine of 30 degrees, but cosine of 30 degrees is root 3 over 2, minus sine of 30 degrees is 1/2, and cosine of 45 degrees is root 2 over 2. So multiplying across and rewriting this as a single fraction, I have root 2 times root 3, that's square root of 6. This is all going to be over 4. Both of my terms have 4 in the denominator, so let's just go ahead and rewrite this as a single fraction right away. The next grouping of my terms, I have 1/2 times root 2 over 2. There's a minus, so minus root 2. So here is our answer, using it with a difference of 2 angles for sine. I can also do this with the half angle formula. So this is the same thing as sine of 30 degrees over 2. This is equal to, Well, 15 degrees is in the first quadrant and everything is positive in that first quadrant. So we're going to use the plus sign in front of that radical. And we have 1, it's going to be minus cosine of the numerator, which is 30 degrees, all over 2. So looking at this, I get 1 minus root 3 over 2. All divided by 2. So again, let's clear the fraction within the fraction. We can multiply by that fancy 1. And doing that, distributing our 2, we're going to get here, this is equal to the square root of 2. The square root. And then underneath that radical, we have 2 minus root 3. All over 4, but taking the square root of 4, that is just 2. So let's move on to question part C, question 2, part C. And so if you're looking at this, you can see that we have sine of 80 degrees times cosine of 20 degrees minus sine of 20 degrees times cosine of 80 degrees. So I see a sine, cosine, minus sine, cosine. That throws up a flag saying, wait, that looks like a difference of 2 angles for sine, which it is. And so let's rewrite that as the difference of 2 angles. This is the same thing as sine of 80 degrees minus 20 degrees. This is sine of 60 degrees. We know that sine of 60 degrees is root 3 over 2. So looking at tangent of 105 degrees, I noticed that I could write this as a sum of 2 angles I know. And so tangent of 105 degrees is the same as tangent of 45 plus 60 is 105. So 45 degrees plus 60 degrees. So I'm going to use this formula for the sum of 2 angles for tangent. So that's equal to tangent of the first angle, 45 degrees. Use the same sign in between the sum of, in this case, the sum of the 2 angles, so plus. Tangent of the second angle, 60 degrees. All over 1, opposite sign, so minus tangent of the first, 45 degrees, times tangent of the second, which is 60 degrees. So let's go ahead and evaluate tangent at those angles. So tangent of 45 degrees, recall, is 1, plus tangent of 60 degrees, that is root 3, all over 1 minus tangent of 45 degrees, which again is 1, times tangent of 60 degrees, which again is root 3. So just rewriting this, I have 1 plus square root of 3 all over 1 minus square root of 3. So in my class, I have my students rationalize the denominator. If you're watching this video to help you with your class that you're taking or to learn trigonometry, it depends on what your instructor wants. So to rationalize the denominator here, I have a difference of 2 terms in the denominator. So I'm going to just multiply by the conjugate of that. So I'm going to multiply by, again, a fancy 1. And then in this case, it's going to be 1 minus root 3, all divided by 1 minus root 3. So distributing, I have in the numerator, actually, I made a mistake. I was looking at this should be plus in between my 2 terms. Okay. So now let's distribute. We have 1 times 1, which is 1, 1 times root 3, plus root 3, plus root 3. Square root of 3 times square root of 3 is 3, all over. The reason we multiply by the conjugate is so that we have a difference of 2 squares. And so just squaring the first term, I have 1 minus the square of the second term, root 3, I get 3. Combining like terms in my numerator, I have 1 plus 3 is 4, plus 1 root 3 plus 1 root 3 is 2 root 3. all over 1 minus 3, which is -2. So notice that I can factor out a 2 in the numerator. Let's actually factor out a -2 just so we can cancel it and we don't have to worry about the negative after. So if we pull out a -2 from the numerator, I get back -2 minus √3 all over our -2. These cancel and we're left with -2 minus √3. Okay, so moving right along, and let's go to our next question. So question number 3 says, given that sine of A is equal to 4/5, A is between 0 and pi halves, so we know it's in the first quadrant, and cosine B is equal to -5/13, and B is between pi halves and pi. So that tells me B is in the second quadrant. So we need to be aware of that when we're doing these. So we want to find, for part A, sine of 2B. And so we can use the double angle. And if you don't remember the double angle, we can quickly get that by rewriting this as a sum of 2 angles. And we would have sine of B plus B, which is sine, cosine. So this is actually equal to 2 sine of B, cosine of B. Well, I know what cosine of B is, but I don't know what sine of B is. And so we are going to create some triangles here. So looking at this, I know that cosine of B is equal to -5/13. So creating a triangle, I'm going to ignore the sign. And just remember that my theta is in quadrant, or my B is in quadrant 2. So looking at this, I have cosine equals 5/13. I know that's adjacent over hypotenuse for cosine. So rewriting that in my triangle. And now we need to find out what the opposite side is. And so my opposite side here, little b is going to equal to the square root of my hypotenuse squared, so 13 squared, minus the adjacent side squared, so -5 squared. So this is equal to the square root of 169 minus 25. This is equal to the square root of 144, which is 12. So now I can go in here and plug in what we have. This is equal to 2 sine of B. Sine of B is opposite over hypotenuse. We're in the second quadrant, so we know sine is positive there. So we're going to have positive. Opposite is 12, hypotenuse is 13. Times cosine of B. Cosine of B we're given was -5/13. So let's just simplify this a little bit. I'm going to first multiply my 2 and -5. That's just easier. That's -10. -10 times 12 is -120. All over 13 times 13, which is 169. So looking at part B, I'm asked to find cosine of A divided by 2. So I'm looking at my half angle for cosine. So I know my formula for the half angle for cosine is plus or minus. We'll determine the sign later. Times the radical, 1 plus cosine of A all over 2. So let's look. We need to figure out what cosine of A is, but in this problem, we were just given what sine of A was. So again, we want to create our triangle. These are not to scale when I make my triangles. Sine is opposite, which is 4, opposite of angle A, and my hypotenuse is 5. So I'm trying to find what this side is here. Let me just call it X, which is adjacent to A. So using that Pythagorean theorem, I get x is equal to the hypotenuse squared minus the opposite side squared, all underneath that radical. So we have the square root of 25 minus 16 equals the square root of 9. So my adjacent side on that triangle is equal to 3. Okay, so now we have our information that we can go back in and plug in what we know. So we need to determine, is that a plus or a negative sign in front of that radical? So go back and look at where angle A is. Well, angle A is between 0 and pi halves. And if I half that, that's gonna make it smaller, but it would still remain in quadrant 1. So we're gonna use the positive. I have 1 plus cosine of A. So using my triangle, that's adjacent, which is 3, all over the hypotenuse 5, all divided by 2. So let's clear the fractions within the fraction. I'm going to multiply by underneath the radical by a fancy one of 5 over 5. So this is equal to the square root. Distributing my 5 in the numerator, I have 5 plus 3 all over 10. So this is equal to the square root of 8 all over 10. And then we can reduce underneath this radical. 8 and 10 both have 2 in common, so I can rewrite that as 4 over 5. Rules, if we have a square root of a fraction, that's the same thing as the square root of the numerator over the square root of the denominator. So we get square root of 4 over the square root of 5. Let's multiply by a fancy one to get rid of the radical in the denominator. So rationalizing that denominator, we can multiply by root 5 over root 5. So before, I'm not going to multiply underneath the radicals for the numerator. I'm just going to first reduce. I know that the square root of 4 is 2. And then we have square root of times square root of 5 all over square root of 5 times square root of 5, which is 5. So part C says we want to find tangent of A plus B. So using the sum of angles for tangent, I know this is tangent of the first angle A, same sign that's in between my angles, so plus tangent of the second angle, which is B, all over 1 minus tangent of the first angle, which is A, tangent of the second angle, which is B. So we're going to need to use our triangle to figure out what tangent of A and tangent of B are. We know tangent is opposite over adjacent. So I'm just gonna come up here and look at my triangle with angle A. So opposite over adjacent is going to give me 4/3 plus tangent of B. So opposite over adjacent, that is 12/5. Zoom back in. All over 1 minus tangent of A, we just saw was 4/3, times tangent of B, which we saw was 12/5. So I'm going to end up clearing my fractions. I will see that my least common denominator of my fractions within my fraction is 15. So let's multiply both the top and the bottom by 15. So if I distribute 15 to 4/3, well, 3 goes into 15 5 times. And so I'm left with 4 times 5, which is 20. Plus, if I distribute 15 to this 12/5, well, 5 goes into 15 3 times. So I have 3 times that 12, which is 36. All over. So I need to distribute the 15 in my denominator. So 15 times 1 gives me 15. And then I didn't multiply it out yet, but in the denominator, I have 15 goes into 15 once. So I just need to look at what is 4 times 12, which is 48. So 15 minus 48 in the denominator. So let's simplify this. I have 20 plus 36. That gives me 56 in the numerator, all over 15 minus 48. I need to think about this for a second. That is 33. And that is a negative 33. So in here we get negative 56 over 33 is our answer. If anything simplified, I would simplify that, but it doesn't. Okay, so looking at our next example, or next problem in this exam, it says, let's find the exact value of sine of, parentheses, cosine inverse of 3/5 minus sine inverse of 1/2. So in here, I am going to, I notice I can evaluate sine of inverse of 1/2. So I'm thinking back of what is the angle of sine that gives me back 1/2. I know that's 30 degrees or pi 6. So if we want, we could rewrite this as sine. And before we do that, let's choose some value. Let's say A is equal to cosine inverse of 4/5. So taking the cosine of both sides, then we know cosine of A is equal to 4/5. So rewriting what we have sine cosine inverse of 3/5. And why did I write 4? I don't know, but that was 3, not 4. 3/5, 3/5. So we have cosine inverse of 3/5, which is A, minus sine inverse of 1/2, which we said was 30 degrees or pi 6. So I notice here I have a difference of 2 angles for sine. I can rewrite that as sine of the first, A, cosine of the second, which is pi 6. Same sign in between, minus sine of the second, which is pi 6, cosine of the first, which is A. We're going to need to create a triangle so that we can figure out what sine of A is. We know what cosine of A is. So make your right triangle opposite of angle A. We don't know, we're going to find, let's just call that little a. Adjacent we have is 3, hypotenuse is 5. So little a is equal to the square root of the hypotenuse squared minus the adjacent side squared, which is 3 squared. So this gives me back 25 minus 9, that's 16. Square root of 16 is 4. So now I can use my triangle to figure out what sine of A is. So opposite, which we just found was 4 over the hypotenuse 5, all times cosine of pi 6. So cosine of pi 6, that's root 3 over 2. Minus sine of pi 6. So sine of pi 6, that is 1/2. Cosine of A, which we said was 3/5. So we have 4 root 3 all over 10 minus 3 all over 10. Let's not reduce that first fraction because we have a common denominator. Let's just rewrite that as a single fraction. And so we have 4 root 3 minus 3 all over 10. Okay, so moving right along, let's go to the next problem. So the next problem in here says, show the following identity holds true. So as I mentioned at the beginning of this video, we do something different when we're looking at identities holding true. We're only working on one side of our equation. Usually you pick the more complicated side. You just work with that one side and you're manipulating it to fall out, hopefully, really easily to equal the other side. So looking at this, I know my left-hand side. So I'm just going to put LHS, meaning that I'm working on my left-hand side. I have sine theta all over 1 plus cosine theta. That fraction plus 1 plus cosine theta, that 1 plus cosine theta is all over sine theta, is equal to 2 cosecant theta. So I'm going to get a common denominator. My least common denominator here, I can see, is equal to sine theta all times the quantity 1 plus cosine theta. So for that first fraction, I'm missing my sine theta in the denominator. So I have sine theta all over 1 plus cosine theta. Let's multiply that by a fancy one to get that common denominator. So sine theta over sine theta. Plus in between, I have 1 plus cosine theta. That 1 plus cosine theta is all over sine theta. So this fraction, to get the common denominator, we're missing the 1 plus cosine theta. So we're multiplying both the numerator and denominator of this fraction by 1 plus cosine theta. So going back, we have sine theta times sine theta. This is sine squared theta. All over my common denominator, which is 1 plus cosine theta times sine theta. Let's distribute for that second fraction, 1 plus cosine theta times 1 plus cosine theta. So distributing that out, I have 1 times 1 is 1. I'm going to have a 1 cosine theta plus a 1 cosine theta. So I'm just going to reduce now. So plus 2 cosine theta. And then cosine theta times cosine theta gives us that plus cosine squared theta. So when you're working with these, you're looking for identities that we know. Recall sine squared theta plus cosine squared theta is equal to 1. So I know that if I group these two terms together, this is the same thing as 1. So let's put that there. So 1 plus the other one that's left in there, plus the 2 cosine theta, all over my least common denominator, which was 1 plus cosine theta, that quantity times sine theta. So 1 plus 1 is 2. And so we have 2 plus 2 cosine theta in the numerator, all over my least common denominator, 1 plus cosine theta, that quantity times sine theta. I see we can factor out a 2 in the numerator. We factor out a 2 in the numerator, we're left with 2 times the quantity 1 plus cosine theta, all over 1 plus cosine theta. That quantity 1 plus cosine theta is multiplied to sine theta. So now that it's strictly multiplication between that 2 and that parentheses and that in the numerator and that parentheses and sine theta in the denominator, we can cancel the like factors, which is 1 plus cosine theta. So we're left here with 2 over sine theta. Well, 1 over sine theta is cosecant theta. So this is 2 cosecant theta, which I was trying to show. So we're done. Okay, so that was the first portion of the exam. The second portion of the exam allows us to use calculators. So the first problem says, on the calculator portion, for the following problem, solve the triangle or triangles, if it exists, given the information. So we're given that the angle of our triangle B is 40 degrees, We're given side B is 4 and side C is 3. So you need to determine if we're going to use law of sines or law of cosines. Law of sines is used. We don't know this is a right triangle. So law of sines is used for non-right triangles when we have an angle and the side across from that angle, which we do. Just to recall, sine or law of cosines are used when we know two sides of the triangle and the angle sandwiched in between. So we're going to use law of sines here. We are going to first look for angle C. And so we know that sine of angle C all over side C, which we're given was 3, is equal to sine of 40 degrees all over side B, which is 4. So let's multiply both sides by 3. So we get sine of C is equal to 3 sine of 40 degrees all over 4. So taking the sine inverse of both sides, we would get sine inverse of sine of C is C equals sine inverse of the quantity 3 sine 40 degrees all over 4. So let's plug that into the calculator and estimate what our angle is. We're dealing with degrees, so make sure that your calculator is in degree mode. So plugging in that calculator, we find that the C is approximately, I'm going to round to the nearest tenth, 28.8 degrees. So I'm going to assume that two triangles exist. If the second triangle doesn't exist, I'm going to get a contradiction. So for triangle 1, I have C is approximately 28.8 degrees. Triangle 2, well, sine is positive also in the second quadrant. So I'm looking at 28.8 degrees as being my reference angle. So 180 minus my reference angle is about 151.2. So C for my second triangle is approximately 152.2. So if we know two angles of our triangle, we can get the third one because we know the sum of all three of the angles is 180 degrees. So let's just first look at this second triangle. So angle A, which we're missing, is equal to 180 degrees minus the sum of the other two angles, 40 degrees plus 152 degrees, 152.2 degrees. Right now I can see I'm going to get a contradiction. I have 180 degrees minus 192.2 degrees. This is less than 0. So this tells me that and a triangle can't have a negative angle. And so the second triangle does not exist. So if you're working through this, I want to see that the second triangle doesn't exist. If you don't show me that, then you'll get some points knocked off on that problem. Okay, so let's go back to triangle 1 and make sure that that one exists. So again, we can figure out what angle A is. We know A is equal to 180 degrees minus the sum of the angles we know, which is 40 degrees plus 28.8 degrees. So we're looking at 180 degrees minus, so 40 plus 28, that's 68.8 degrees. 180 minus the 68.8 gives us back 111 0.2 degrees. Okay, so we know that our second triangle exists. We found out what angle A is. We found out what angle C is. I'm going to say approximate because we've been rounding. Now we just need to figure out what side A is. So side A, well, we can look at side A all over sine of angle A, which we just found to be 111.2 degrees, is equal to, let's use what we're given. So side B, which is 4, all over sine of angle B, which is 40 degrees. We can multiply both sides of our triangle by sine of 111.2 degrees so that we can get A by itself. So we get A is equal to 4 times sine of 111.2 degrees all over sine of 40 degrees. So plugging that in, again, make sure your calculator is in degree mode. So 4 times sine 111.2. That is all divided by sine of 40. So we get here that this is approximately 5.8. Okay, so moving right along, let's look at the next question. Okay, so in the next question, we have a word problem. So let's read through this first, and then let's pick out information that we need. So we have a cruise ship maintains an average speed of 15 knots and going from San Juan, Puerto Rico to Barbados, West Indies, a distance of 600 nautical miles. So to avoid a tropical storm, the captain heads out of San Juan in a direction of 20 degrees off a direct heading to Barbados. The captain maintains the 15 knot speed for 10 hours, after which time the path to Barbados becomes clear of the storm. So through what angle should the captain turn to head directly to Barbados? So we're looking at finding this angle in here. Okay, so we need to figure out some stuff. Let's look at this. We don't have enough information right now to do anything. We only have one side of our triangle and one angle, but we know that in here that the boat was traveling at an average speed of 15 knots, for 10 hours. We know that distance is equal to rate times time. And so the distance here is equal to the rate of the boat, which is 15 knots, times the time, which was 10 hours. So the distance here is 150. And in here, they're nautical miles. So nautical miles. So we know what this side of our triangle is. And so we have this side of our triangle, we know what this side of our triangle, and we know the angle in between. So we just discussed that we use law of cosines if we know two sides and the angle in between. So let's figure out first what this side is. So we can figure out what that side is. Maybe let's call it X. We can figure out what X is by using the law of cosines. So the law of cosines says X squared, that side squared, is equal to squaring and summing the other sides. So 150 squared plus 600 squared minus 2 times the length of one side, 150 times The length of the other side, 600 times cosine of our angle in between, which is 20 degrees. So let's plug that into the calculator and figure out what we have. Okay, so going in and plugging that into the calculator, you should get that x squared is approximately 213,355 and 328 thousandths. We need to take the square root of that. And so doing that, you get the square root of that number is approximately 462 nautical miles. So that still hasn't answered our question, but we've gotten a lot of this information on this triangle. And so I know that if I can find this angle here inside the triangle, where this boat is changing direction, I can find the angle outside the triangle by looking at 180 degrees minus, let's call the angle inside the triangle theta. So I know a side opposite of the angle I'm trying to find right now. And I know a side opposite of an angle given. And so let's look at that. So I have, using law of sines, I have sine of theta degrees all over the side across from it is 600 nautical miles is equal to sine of 20 degrees all over 462. Multiplying both sides by 600, I get sine of theta is equal to 600 sine of 20 degrees all over 462. Taking the sine inverse of both sides, we get the following. We get that that is approximately, theta is approximately 26.4 degrees. So the bearing and they need to turn. We need that 180 degrees minus the angle we just found, 26.4 degrees. So they need to turn 153.6 degrees. We call that angle A. So I noticed here when I was doing this problem or writing out the solutions that this, you can see this image that is given of what's going on is not drawn to scale. Okay, so let's go to part B of this problem. It says once your turn is made, how long will it be before the ship reaches Barbados if the same 15 knot speed is maintained? Put your answer in terms of hours and minutes. Okay, well, we figured out what that distance was once we changed our angle, was 462 degrees. So again, we're going to use the fact that distance equals rate times time. We're figured out what that distance was. That distance was 462 nautical miles. We're given that our rate is 15 knots, and we're trying to figure out the time. So we can divide both sides by 15. And we get that T is approximately 30.8 hours. It told me I want to put this in hours and minutes. So I have 30 hours. I can figure out the minutes by looking at 0.8 times 60, which is 48 minutes. So C, how much time did the cruise ship lose because of the storm? Well, let's look at the time it took because of the storm, the time it would have taken if they would have done the direction straight, would have gone straight there. And then let's subtract those two. So because of the storm, the trip took that initial 10 hours plus that 30 hours and 48 minutes. Or it took us 40 hours and 48 minutes. If there was no storm, well, the distance was 600 nautical miles. We know that they were going 15, the distance equals rate times time. 600 nautical miles, rate was 15 knots. So we can get the time by dividing both sides by 15. I should be able to do that, but just to go faster is 40. So without the storm, it would take 40 hours. So the extra time was at 40 hours, 48 minutes minus the 40 hours it would have taken. So it's just extra time was 48 minutes. So that was the end of that exam. So in our book that covered most of chapter 8 and chapter 9, your exam also has from our book chapter 10. Chapter 10 covers polar coordinates. It covers complex numbers and putting it into polar coordinates and exponential form. It covers de Moivre's theorem. It covers vectors. And so let's take a little bit of time to review some of that information. So I'm going to put that information on a new video.